Welcome to the first podcast we've got for the briefing room. And today we'll be covering digital engineering and what it is. And today I've got with me Andy or Andrew? Andy. Okay. So welcome, Andy. Do you want to just give a brief...
So a little bit of background. I've joined a few months ago as the simulation, modelling and analysis capability lead in the capability sustainment team under Ryan. Previous to that, I've worked at General Dynamics, BAE Land Systems, Rolls-Royce Submarines, Jaguar Land Rover and Babcock, so loads of varied industry experience doing similar roles to this.
Okay, so today we're just going to go over digital engineering from an outsider's sort of perspective. We want to also give a little bit genuine information to experts in your field, in a similar field, and people who have never heard of it, like myself. Before Ryan brought up digital engineering, I was like, what's that? So all the engineering I've seen in this company, with our technical publications, all of it's on computers, so I thought that was digital already. Can you just enlighten us with the first question I'll ask today? What is digital engineering?
Okay, so digital engineering is a modern approach to product and system development that utilises digital technologies to create data, analyse, manage complex situations throughout the life cycle. It's not just about digital tools. So like I say, everything on a computer, you think that's digital. Yes, but they don't always talk to each other. And the engineering thing, it's about creating one single source of truth.
Okay.
So all of those tools talking to each other and making sure you've always got the latest information. So emphasising collaboration, making data-driven decisions. And it's also a lot more efficient, quicker, in theory cheaper.
Okay, so this is, you're going to hate me now, this is slightly going off script, not one of the questions we pre-agreed, but if I was a potential customer or client, got very little time, I jump into an elevator, you spot me, you want to give me an elevator pitch, you've got literally 30 seconds, maybe a minute until I get to my floor, you jump in the elevator, how do you sell me digital engineering? Like, why should I think about digital engineering?
For me, it's a quick, cost-efficient way to provide evidence in the decisions you're making. So do you go with supplier A, supplier B, which is going to cost? Cost is always a big thing, but is it going to cost? Is it going to provide you the solution you want? Bids have always gone in with big, huge documents saying, yeah, we'll do this, we'll do that. If you have these models, these simulations, you're providing some sort of level of evidence other than go on, trust us, it will work. So for me, that's where it gives that.
Okay, so it gives the evidence, it's sort of the data and it backs it up. How does that differ to digital transformation?
So digital transformation for me is there's a lot of overlap, you do need it. A lot of the digital transformation was moving, historically a lot of stuff used to be done on paper. So if you think of the drawings when they were designing a new tank, 30, 40 years ago, it would have all been done on big drawings and they have whole rooms of people designing them. Now it's all done on CAD.
Right.
And it's about that next step of taking those CAD drawings and connecting that with the LSAR, connecting it with the tech pubs, connecting it with the safety. So again, you've got that one single source of truth rather than multiple areas that are possibly out of configuration control. So it's about integrating all those and getting them to talk together and getting them to work together.
Okay. So what sort of tools are used in digital engineering? Are there certain tools that everyone uses, or is there tools that we've made ourselves? What kind of activities and tools fall under digital engineering?
So for the stuff I do for digital engineering, it's all the simulation, all the modelling and the data analysis type tools. Right. So there is a few sort of industry standard tools out there, whereas we're sort of software agnostic. There is things like the Systicon tools, right, Opus 10, Simlox, or the TFD tools, and they've been around for 20, 30 years.
Is it a one-stop shop of you just choose one and then hope that some of your clients use that sort of same one as well, or is it you can use multiple on?
You could
every
use
case?
more. In general, they'll give you pretty much the same results.
Okay,
It's
but we have the capability
Yeah.
of we can use several. We know how to use several.
it's like Apple and Android on your phone. Some of the features are slightly different. You can still make phone calls. You can still go on the internet. You can still send messages. They've both got advantages. Both got disadvantages. And it's really whichever the customer feels most comfortable wanting to use. They may already have the software, so we could do that with them. And that's sort of just the first step of it. You're then talking discrete event simulation. There's many tools out there you could use for that. That's where it goes on to a little bit more room for improvement, room for scope for going beyond the standard sort of setup of a tool. That's almost writing, again, going back to the phone analogy, it's almost writing your own little app in the phone to do what you want to do rather than using the standard operating system.
Okay, so in terms of, we've talked about tools and tools of activities that fall under digital engineering. What about simulation, modeling, data? When I hear those terms, I just think sort of someone on a desk in sort of the matrix background behind them, typing away, the matrix code sort of coming down. Can you simplify what goes into the data, what goes into the simulation?
Yeah, and again, there is a lot of that data. So it's all the ILS outputs, all the LSAR data, bombs, FAMICA data. And again, one of the key things to all of this digital engineering is the quality of the data. If what's in the LSAR isn't any good, doesn't matter how good the digital engineering or the simulation or the models are, you're not going to get good output. So again, it's having that quality information in there in the first place and up to date and live. Okay. Because a lot of the LSAR is perhaps done in the development stage. It needs to be kept up to date as we move through the whole life cycle of the vehicle. Same with the utilisation of the vehicles, for instance. The MOD at the start of a contract will say, we're going to use this vehicle in this way. 5 years later, the world's changed, the requirements have changed. If you don't rerun the models at that point, you're not optimising your solution, you're not getting the most out of it that you can.
Okay, so is digital engineering sort of like a growing thing? Are there different aspects of that add to digital engineering, or is what digital engineering now will not change? Is sort of when you're adding LSARs, is it going to be more things that sort of add into digital engineering down the line, or?
I think so. There's I view it as very data hungry. The more data you've got, the better it can be. The more it's amazing with Amazon now. You order a parcel and you can watch it come down the street 3 stops away, 2 stops away, 1 stop away. We're obviously not quite there yet in the defence industry. You know exactly where is every single tank? How much fuel have they got left in there? How many bullets have they fired?
Yeah.
You know, when is the radio going to break down? We're not there yet. Whether we will ever get there or not, I don't know.
If we did ever get there, from your point of view, would you think digital engineering would be one of the main catalysts to get us there?
Certainly, it would definitely be helping. There's a lot of stuff we could do. You know, taking all that and having all that live information, it would then almost become almost like playing a computer game and watching all your tanks on the screen. And if we get it live, if we get the visualizations in there, it could be really exciting. And it's all about, when you get to that stage, you know, the in-service vehicles and stuff, it's all about trying to predict the problems that are going to come up. And you won't always get it right, no matter how good we get. Yeah. We'll never know when something's going to fail, because if we ever got that, none of us would be here, because you'd be predicting the stock market, and you'd be a millionaire and you'd be long gone. Because it's the same sort of principles, the same as predicting the financial models, but we do this to predict what equipment do they need, what support do they need. And some of it can be incredibly short term. Yeah. Like, for instance, you know, there's stuff going on in Ukraine and things like that, what support's needed for that. And a lot of it is more longer term. How many trainers do we need to train to maintain these vehicles in 10 years' time? Maybe 10 years is too far in the future, but in 2 or 3 years' time, because you need to recruit the people now, you need to train them, and you need to get them there ready for when the vehicles go into operation. You can't just drop them and go, oh yeah, the MOD will have 100 people to support these new vehicles that needs all this new skill set because it's a different vehicle. So again, the digital engineering can give you that, how many of these people will we need to train?
Okay. What would the same project, so digital engineering, a project that involves digital engineering, what would the same project look like without digital engineering? Before digital engineering came along, using conventional methods, how would that look? What's the differences?
For me, from my experience, those projects would have tended to have been a bit more bloated,
Okay.
because it would always have been a bit of a safety first, not in a safety sense, but in a meeting contractual obligations.
Okay.
You know, so things would be a bit over-engineered. They wouldn't necessarily meet all of the requirements as efficiently or effectively or as quickly as they could, because the data wasn't there to help back up the evidence. So, for instance, if you were doing the spares, I think one of the things they used to do is, right, we'll hold 30 days spares.
And that knowledge was from like past experience, or
Historical.
just someone sort of licking their finger, sticking
30 days, or it'd have been the contract, the MOD, we want 30 days spares because we know if we hold 30 days spares, they're almost thinking it'll be 30 days before the next supply truck turns up.
Right, okay. So, and then I imagine then that wouldn't be accurate for, like, say, equipment A, equipment B, equipment C. You're doing 30 days for all of them. Equipment A might be really good, and you don't need to have 30 days worth. Whereas B and C might need 15 days, and you'd be off by 15 days, and you'd be waiting. And then you've got different prices as well, I imagine. So
the cost does come into it. And again, an old historical thing is, well, we've got to have one of everything.
right, okay. So I just imagine that being a bit expensive on if a piece of equipment that now you're saying you have the data that will show you don't have to have 30 days, and you're keeping 30 days in the past, and you only need 15, that's like double the amount, and you're paying for double the amount and storing double the amount.
Space and the moving it around and...
Right, okay. Right, I get that bit now. Okay, sorry, I sort of jumped in and I just needed to set, what was in my mind. I was like, right, I just need clarification on this. But yeah, I'm on the right page. Okay, cool, I'm following.
Yeah.
Back to you.
And also the other thing is as well, previously, without doing all of this, you wouldn't necessarily have identified some of the issues and some of the problems until the vehicles went into service.
Okay.
Because when you've got hundreds or thousands of parts, maybe all the analysis wasn't done on all of them. They're just on what was considered critical parts. So having the digital engineer, being able to effectively and quickly do it, and again, keeping up with the latest version as designs change, as things drop in and out, as it goes through the design cycle, sometimes there wasn't always time to check it. With the digital engineering, it is a lot quicker, a lot more efficient to look into those. So you can almost feed back into the design if you're doing it early enough.
Is it just about making things faster or more efficient, or is it both? Or
there's definitely faster and more efficient in that. Again, using the same data.
Yeah.
You know, I've worked on numerous projects previously where you spend 2 months working on it, and then someone goes, "Why aren't you using the latest version?"
Right.
Which I'm sure numerous people have done that.
Yeah, I'm getting flashbacks now. Painful flashbacks, but
yeah. In theory, that shouldn't happen here because you're all looking at the one data source of information, so it's all connected. So you're always pulling the latest stuff. So you wouldn't have that inefficiencies. And it would make things faster as well. You know, computers, they're getting faster and faster all the time, and more capable. When I was doing some of this stuff 20 years ago, it'd be set it up for the weekend and come back on Monday, see what results you got out. Now the computers are so fast, you're talking minutes or maybe hours to get the same sort of thing, which allows you to run more options, more scenarios, explore more things to be more certain that what you're getting out is a really good answer, really well backed up.
So then would that change how teams work together? So sort of not specifically people inside the same team, but if you've got some people doing the LSAR, you've got some people doing other bits, and they're all working from one central source of data, would that then change how they would usually, without digital engineering, sort of contact each other and sort of work together? Or would it be less likely, like say again, working from old data or working on old models, is it less likely to do that now? And sort of, is there like less or more communication between teams?
It should be more communication, better communication. Possibly, when you're updating something, letting the other people know that you updated it or you're about to update it.
Right.
So again, they don't start on work and it changes halfway through. Equally, I think there's a lot of possibly tailoring of things like LSAR for what information is genuinely needed, what isn't, what is superfluous, and that sort of from different areas, and everyone will have their own things. And
so documentation, does that change with digital engineering model, the documentation?
Not a great deal, I don't think. I think it will provide a lot more evidence in say, case reports, bids. It certainly won't remove the need for the documentation, I think, as we discussed that. It's all gone digital anyway.
Yeah.
Long gone are the days of printing off bids and A4 folders being given in there. So again, it also enables those to be updated a lot more quickly and efficiently. If you tie it all up properly, as soon as the updated information is in there, you can pull it straight into a bid or a case report.
Okay.
So again, more efficient, more quicker, delivered almost instantly to the customer.
Why? How would this digital engineering add value to organisations such as the MOD or the MOD? Or, like, why, with such vast organisation like the MOD, how would this add value, or how would it be valuable to them?
It's something that has come up in the Defence Review recently, where they want to, again, maximise efficiency. It's something the government says every 10 years or so. Getting the most bang for buck, getting and reducing costs as much as they can, and also wanting to, I think there's a drive now for it being more capability based rather than quantities. I want 100 tanks. No, you don't want 100 tanks. You want enough tanks to be able to do whatever operations you need to do.
Right.
And the only way to prove the capability is with stuff like this, is with digital twins and doing scenario modelling to prove that what you've got is capable of providing what the MOD needs and what the government is prepared to pay for.
Can I just jump in on something you just mentioned then, digital twins? So that's a term I've heard sort of floated around. What actually is a digital twin? It's, to me, it's in my mind, it's like creating a clone of either yourself or a piece of equipment. But one, how do you do that? Two, is that actually what a digital twin is? And three, how do you use that?
Yeah, so it is. It could be, again, like you say, yourself or an equipment or a system, a process. And I think the digital twin aspect of it comes from, I think it's a new phrase for something that's been going on for a while. It's, we don't design equipment here. If you were designing a CAD model, and if it was all perfect, you'd say that is a digital twin. But what you need to do is keep it up to date. So the digital twin has to be live. You could create a copy of it right at the beginning. 5 months later, it's totally different. A digital twin of a system. So it has to match it perfectly. You have to be minimum assumptions. So it is that sort of thing. It's a real-time replica of a physical analysis that allows analysis, testing, and optimization.
Okay.
So you can play around with it. You can see, if we did this, what would happen?
Right. Okay.
It's probably a little bit more than CAD. I'm no
Yeah.
CAD expert. I don't know how much you can play around with CAD and see, right, if we change this in the CAD and we drive it over this terrain,
Yeah.
how's the vehicle going to hold up?
Right, okay.
I know they do
you
a
can-
lot of stress analysis on there.
So you can sort of change the scenarios, and you sort of, without actually messing with the main one, you can see how something would
Yeah,
sort of affect
Yeah.
the digital twin. That can sort of better.
the tanks, for instance, if you're driving a
Yeah.
tank across mainland Europe or you're driving it across a desert or the Arctic,
Yeah.
the same tank is not going to behave the same way. So if you've got a digital twin with enough information, enough data, and enough on those environments,
Yeah.
you could put it through those and go, right, in these different environments, these are where we're going to have the different problems.
That'll influence your decisions then on sort of later down the line, and yeah.
Yeah, and it's the same for the support solutions. If we operate these aircraft in this environment,
Yeah.
what alterations might we need to make to the support solution? You know, are we going to need more maintainers, more fuel, more spare parts?
Okay, so yeah, again, I was just beating off the track a little bit. I just heard the term used a couple of times, and I just never actually had it explained or sort of what it actually is.
But it's like I say, a clone, a copy
Right.
of something real that you can play and poke around with and see how does it react.
Okay.
Another thing about it is, again, it takes a lot less time to build a digital twin rather than a real thing.
Yeah.
Back when I worked at Jaguar Land Rover, they still build clay copies of the cars before they go into production
Right. Okay.
to do wind test analysis and all that.
Yeah.
Again, if you did a digital copy, that would be a lot quicker and a lot easier and a lot quicker to change. And
I feel that the clay sort of model, that's sort of something they would do back in the olden times. That's not something I imagine they would do now. I thought it would all be digitized, and it turns out that's the digital engineering and the digital twinning. But have you got people who, did they do that because they didn't trust the data from a digital twin, or you always get skeptics that go, "Oh, I'm not going to trust that because how will that digital twin or that software know what will happen to an actual physical?"
yeah,
Is there enough data to sort of show it is reliable?
I think there's now, and I think there's a lot of companies getting
on board with
customers to be on board to buy into it, and a lot of it's overcoming that. Well, we've always done this, and it's like it's a big thing to go. Yeah, we're totally not getting rid of the physical thing. We are just going to go pure digital.
Because there's always something about nostalgia, and if you use clay models, it's all like traditional and everything we've done in the past. It's nostalgia, but yeah, I didn't know if it was a case of nostalgia or people not wanting to, not trusting the data, or because I imagine organisations like the MOD, to make such a big leap and go into digital engineering, put so much on digital engineering, there needs to be more trust on the data.
Yeah, definitely they need to buy in and trust the data, and that's why sometimes we might have to start with smaller projects to build up that trust. And that, you know, are they going to do that for the next submarine? Probably not. They are probably still going to build little models and put them in water tanks and all of that, rather than go, yeah, we trust the digital engineering to be perfect on that.
So in my mind then, take the submarine idea. Would it be quicker and faster, same thing? Would it be quicker and cheaper and have less people involved if you did it all in digital engineering, digital twinning, and all that goes with that, or creating the models and testing it in water tanks? Is there a case of you can just do it all in digital engineering, or is it still a case of they should still do it in water tanks?
I think now you could do it all in digital engineering.
Because submarines, a lot of money, but then, as we've seen in the SDR, there's going to be emphasis on more. So would it be cheaper to have it all in digital engineering and digital twinning rather than creating physical, I don't know how much models and doing all the testing, but I imagine it involves a lot more people than digital engineering.
Yeah.
and then so that's people's time, money, and then costs for it. And they've probably got the tanks already that they've done before, but there'll still be a cost, an overhead.
Yeah.
So would you sway more towards doing it wholly?
I certainly would.
Wholly?
But then that's my area. That's where I
don't
work.
know if it'd be like a 50-50 or 60-40, or if you do 100%.
Yeah, and I'll be honest, I don't know how much they do now. I'm sure, the new Dreadnought class, I'm sure that is far more digital engineering than the V class was 30, 40, 50 years, however long ago they were designing it.
Yeah. In my mind, if something was a small cost, I'd be like, okay, yeah, give digital engineering a chance and digitize it. But something that costs a lot more, hundreds of millions,
and it's convincing because if you get it wrong, if you try something new and get it wrong, you'll get the blame and you'll never get to do it again. If they do what they've always done and it goes wrong, everyone just goes, that's just the way it is, isn't it? No one seems to care too much about that. And again, it's also a lot of this is like a lot of ILS stuff. It's about spending a bit more up front to save money later on.
Say for some of the viewers, ILS, that's integrated logistics support?
Yeah.
Right, okay.
Yeah, so it's doing that. It's making sure, a phrase I've heard, designed for support. Okay. So that it's, they've got the ability to do the repairs without ripping half the vehicle apart. Again, so many anecdotal stories about aircraft built too big to go in hangars, so they have to deflate the tyres to roll it into that, because no one considered that when they were designing it. They were just doing what's nice and what's it.
Yeah.
The new submarines, I think there was a story in the news today about Clyde getting a big funding because they need to redo the dock up there so the submarine fits in it.
Right.
Now, it might just be that submarines have naturally evolved in such a way that they no longer fit docks that are decades, centuries old. So there's a bit of work going on there. But in a perfect world, you perhaps look at what size dockyard have we got? Right, we need to design the sub to go that. The same with the aircraft. You could make an amazing aircraft and then go, all our runways are 10 metres too short, so we can't launch them.
On that then, have you got sort of an example of where digital engineering has made a real difference or sort of added value? Do you know of an example?
One I did a few years ago was a demand satisfaction model. Okay. So the contract was the sparings, so for a fleet of vehicles, there was a demand satisfaction. They had to achieve 90% of the demand satisfaction rate. Okay. Again, with cost being optimised. Because again, you could achieve that by going, we'll have 1,000 of every component. You'd need a warehouse 10 times the biggest B&Q in the world sort of thing, and everything in there, and you just have huge cells. Yeah. So you've also got to go, right, no, we need to be efficient as well. We don't want to hold 10 things that we can buy quickly, easily, and effectively and get delivered the next day. Yeah. And I did again, using some of the standard tools you can do, I did an initial model on that, which gave a reasonably good, it was, that's what they believe would achieve the 90%. Then I built a digital twin of the support solution. Okay. So, same vehicles, same locations, same pipeline times, same failure rates taken from the LSR database. And then I started playing around with scenarios because, again, you get the utilisation. It's going to do an average of 100 hours a year. Yeah. Okay, well, what if you do that whole 100 hours in February? Because you could, and you're still contractually in what you said you're doing. And again, a lot of the standard tools don't deal with that. They take the 100 and go, right, on average. Okay. So, and again, you can play around with that and tweak the number of spares because there was huge penalties in the contract for not achieving the 90%. So again, it was, right, we want to go a little bit over. Where do we need to go over to make sure we don't? And equally, again, there was some trade-offs. Yeah. You're getting rid of one expensive spare and getting 10 cheaper spares because overall you met the demand satisfaction. So again, running these models overnight, you could play different scenarios and go, right, if this happens, if that happens, we're still going to be okay, because it was still within the terms of the contract, if not necessarily the spirit of it. So that was and we were talking millions of pounds here, not tiny little stuff.
Did you sort of feel the pressure when it's that sort of value? Do you feel the pressure then on the thing you're creating, the digital twinning? Is there a degree of more pressure that builds on you if the size of the contract's bigger, or is it you know the data will be fine, you know the analysis will be fine, digital twinning will be sound? So
I have huge belief in the numbers, in the process, in the models, because again I had the model V&V'd independently, so I knew it was doing what it was supposed to be doing.
Right. Okay.
I get more nervous about the data I'm putting in there.
Okay.
Is the utilisation right? Is the number of vehicles right? Is the failure information correct? Are they going to use it as much as they said they were going to use it?
Yeah.
I've worked with people in one of these. I've just took out a hire purchase on a car, and I've said, I'm only going to do 500 miles a year, knowing full well they were going to be doing 20,000 miles.
Right. So it's all the data that goes in. That is the important part. That is the make or break sort of. If any of it is wrong or someone's put anything sort of exaggerating, then that is what can potentially cause problems in the future. Right. Okay.
And again, so when it comes to the cost side of it, these are crazy numbers that, it's a number where it's almost unreal. When you're talking
So
multiple millions of pounds.
Oh, so it's much more than the hire purchase on like a car or
Yeah.
a Fiesta. It's
It's not like when you go and do your shopping, you go, right, do I buy product A or product B? Oh, it's 5p difference. I have got a concept of that.
Yeah.
Is my sparing solution 56 million or 57 million? I concentrate on, if I've got the right number of spares, the price is what the price is.
Right. Okay.
Then it comes down to commercial negotiations, what the customer can afford. And again, there was some back and forth on that. And it was a case of, okay, we can drop the cost. If you drop the cost, this is the risk you're exposing us to. So we probably wouldn't want to sign up to that contract.
Right. Okay.
So again, it's providing that information so that when you go into the negotiations, you know what you're signing up for, rather than just going, oh yeah, we'll fudge it, we'll be okay. I think that's, without wanting to disparage any commercial people, sometimes they don't understand the engineering, the numbers behind it. And again, now that the computers are getting quicker and faster, you could almost sit, if we get the tools built properly, you could almost sit in the meeting and play around with it and go, right, if you want to do this, this will be the implication of your decision.
So this is something that you can do live as well. I don't know how much processing power or building your different scenarios, but this is something that you can do in real time if you're in a negotiation.
I think it's moving to, it's getting closer to real time with better computers, depending on the size of the thing. If you were to try and model every vehicle in the British Army for the next 10 years, no, that's not going to do. If you're going to model one aircraft for the next 6 months, that's the sort of thing you could sit in a meeting and play around with numbers.
Right, okay. Right, so there's, at the moment, the limitations would be, one, the size of the actual project, if it's going to be numerous thousands of vehicles, and then the other one would be processing power, so computers. So in 5 years, 10 years, we don't know how fast laptops and other databases is going to be. Okay, so that all sounds fine. It all sounds like the world is moving to, and organisations are moving towards digital engineering, and it can save you money. But there's bound to be some downsides or some weaknesses. So what's the biggest problems facing digital engineering? Is it people buying in
there's
to
definitely
the idea?
A buy-in side of it. Again, trusting that the numbers will give you what you want, will be backed up by reality. And that takes time, just to get people to buy into it, to be brave, especially if sometimes it means perhaps a little bit more cost up front. again, there's that I don't want to pay for something that I'm not sure is going to save me money.
Right. Okay.
Because again, these software tools, they're not necessarily cheap.
Yeah.
The people to run the software aren't necessarily cheap resources to get in.
Just trying to convince people that you pay more upfront at the start to save you in the long run. If something is going to last, you're hoping for it to last like 5-10 years. Once you get to a certain point, you're saving money, whereas normally you'd be spending a certain amount throughout. There'll be sort of a dip where you'll then not be spending as much. But yeah, I can see why it'd be hard to convince people.
And also these models, they're not quick and simple things to build up. They're not. Once you've got them and you can play around with them and do the scenarios, that is quick, but it can take a significant amount of time to get them built, to get them correctly representing the real world.
How long would it be to take, say if I had a fleet of 10 subs, how long would that sort of take to build? Not down to the weeks, but like how long realistically? Are we talking months, or are we talking about a couple of weeks, or like 2 years to build? Or so it'd be multiple factors that you'd have to put in, but how long does it usually take to create something? Maybe 10 subs is a bit too big, but
no, I mean, once, because again, it also comes down to, are those 10 subs identical?
Right. 5 on one, 5 on the other.
But even then, so you've got to, and again, if you set them all up right, it wouldn't be too much of a difference between 2 types to, even if all tech was slightly different. And the support solution, probably, there's 2 elements to it. There's the physical time it would take, which you're probably talking a few weeks, maybe a couple of months.
Okay. That's shorter than I thought.
Yeah, but that's because it's and then there's how long would it take calendar-wise? Because what you'll have is a lot of the data will need cleansing, will need discussion. You'd have to, your support solution. You'd need to be sitting down and discussing that and going, right, is that genuinely what you mean? And you'd possibly go through a few iterations of that. And again, a lot of it will depend on exactly which bit of software you decide to use, and again, how many people you throw at it. Some of these things, from past experience, sometimes you can. It's almost like software development. It's sometimes better to just have one person working on it so that you're not confusing it and causing crossovers and overlap.
I just realised I read the last question wrong.
Right.
It's not what's the biggest problems facing digital engineering. It's what are some of the biggest problems digital engineering helps solve.
So for what we do, for the support solution side of it, it is all about making the equipment better supported, so more available for the end user. So potentially less equipment, but more available, which is the sort of ideal golden dream solution, ideal world. Less equipment, cheaper, more available. It's always there when you want to use it. It's almost like rather than buying a car, you rent a car, and it's always there when you walk out the house to use it, and you're only paying a fraction of what you pay. That's what it could do. Yeah. But to do that, you'd have to model everyone in the maybe in the city, and their car needs, and how many cars you need, and so you're almost looking at that's what it could do. Okay. Again, cost is always in there as well. So you could provide. Well, hang on. What could we do? How cheap could we cut it? Yeah. And equally, if it's done early enough, you could feed back into the start of the thing. If you change this part of the design, this is the impact it could have.
Right, okay.
Again, that design for support, design for maintenance.
So digital engineering would sort of be at the start of the project. Best to bring it in straight away, because then what you said is that it can you can run through it, and if one bit was changed at the start, you can make recommendations, and then before they go and set in stone, this is what we're going to make, they can then rely on your sort of observations and your recommendations, and they can possibly change the initial design. Okay, so the earlier the better.
So certainly there's an element of that. I think a lot of what we do, it's almost been designed, been agreed. There's minimal changes we can make, because again, it's always a compromise. It's like, yeah, if you change this, it's going to cost £2 million, and you're going to save us 20 pence. Yeah, we're not going to go for that. So again, it's always that time, cost, quality sort of triangle as to what can we do.
This all sounds great. What is stopping everyone from doing this already? Like, why is it not the norm already?
I believe there's pockets of this being done by some companies to some extent. I think there's a lot of, we've talked to before, you have to buy into it. You have to have that belief that it's going to give you the outputs, and you have to follow it as well. It is also implicit in some of the desk stands that you should be doing modelling and simulation, but it isn't stated explicitly, so there are ways around it if you don't want to do it in any great level of detail. You can do a very light touch, and again, depending on the size of the contract, the project, they might go that stuff, because it is a tailored approach every time. It's not a one size fits all. Not everything needs the big full blown, perfect matrix sort of level of digital twin. Sometimes it could just be a very basic Excel model giving you the numbers you need. That sort of stops some people. And again, there's always, well, we've never done that before and it's always been okay.
So it's a mindset.
There's definitely a mindset change needs to go on. I feel as well there's possibly a little bit of, I've got to be careful how I phrase this. You might need to, again, it might be, I sometimes feel there's a little bit of suppliers going, if we don't do this, we can get more work. Again, sometimes, you can see
I see the cogs in the head, sort of like trying to.
I don't want to go on the attack to too many people on too many things.
Do you see that in the future, do you see the people coming through, they'll be more acceptable of it and accept it a bit more, and their mindset will change, and they will come into their roles where they feel, oh, are we not doing digital twinning already, and we should be doing it, and then we'll see on more sort of bids coming through that it'll be more of a requirement.
I think so. I think they are going to look at putting it into trying more requirements. One of the working groups I'm involved in, they are trying to push to try and get it included in a lot of the MOD contract requirements. I think a lot of younger people will go, why are we still doing all this old stuff? Why don't we just do it as a...
So do you feel at the moment it is us and the equivalent sort of shouting and screaming about digital engineering, and we should be doing A, B and C, digital twinning, and maybe they're not listening as much, and then once sort of younger, new people come in and expect that, and go, why are we doing it the old way? We should be doing this. They'll sort of flip over, and they will then be requiring us to, or looking for people who are offering digital engineering, and then they were like, right, okay, is it going to sort of flip around, do you think?
I think so. I think that's the way it's saying, because again, it does save money, and that is always maybe not so much the MOD's top priority, but certainly the government. And again, I think the MOD, that maybe was a bit flippant. They don't necessarily want to spend more money, but they want to spend it where they want to spend it. So if they can get good value, and I think that's where you have to look at it, getting the best value, making it more efficient. So optimizing things rather than trying to do it on the cheap. So again, I think there'll be a lot of that. And again, I think you also have to look at things slightly longer term as well.
So with looking at longer term, my last question to you, or last one that we've scripted and written down, is where is digital engineering heading, and where do you see it in the next few years sort of evolving and heading towards?
So I think there'll be a lot more digital twins. I think they'll get better. I think they'll get more accurate. I think there'll be a lot more AI as well.
Now, so we haven't even touched on AI in this conversation. Is that something AI is sort of in the last couple of years with generative AI, that it's sort of in the press and everyone's sort of making a big hoo-ha about it. Whereas firms and tech companies have been using AI for years. They just haven't called it AI as a product.
Yeah.
So it's been on your phones for years. But now everyone's like, oh, the new hot thing is AI. So they're like, oh, we can do AI this, AI that. Does digital engineering, has it got any sort of, do you utilize AI at all in digital engineering? And if so, are there any issues with incorporating AI into something that's going to have so much data, or is it beneficial to have AI to sort of help with the amount of data that's in there?
I think it will be. I think AI is brilliant for dealing with huge data sets and possibly, spotting errors, issues, smoothing things out, maybe even filling in some of the gaps. I think you also have to be careful with it. I think there's various security issues as well.
Yeah.
And like I say, I think a lot of stuff, it's been using not necessarily AI, but, and again, it's trying to understand exactly how a bit of software works. If you introduce AI into that, it's far less predictable. And it needs, a phrase I heard recently was almost HAI with a human element. So the AI does something, but the human checks it.
Right, okay.
So we'll run it through AI and see what the AI says, and then we'll just have someone double check it rather than just straight away going, yeah, that'll be fine.
Okay.
Because again, it has moved on amazingly over the last few years, and I'm sure it will again. The other thing as well is you need the data to train it on. So if we are still years away from going to ChatGPT, right, give me a cost model for the next aircraft carrier that the UK is going to build.
Because if you're talking about mindsets earlier about people trusting the data, and this is digital engineering, you've still got people then who do exactly the same about AI and don't trust AI, or it's like there's a whole conversation piece around that. But do you feel in the next couple of years AI being more involved in digital engineering, or
definitely.
Okay.
Definitely. Probably more doing a lot of simple tasks to remove some human error from things.
So removing human error and then possibly saving time, which then would bring down costs as well.
Yeah.
Again.
I think doing some of the boring, repetitive stuff. I've seen it used in cost models for counting number of light switches in a building.
Okay.
So previously, what you'd have had to have done was go through all the drawings, go right, how many, and you can set the AI off and go, this is a light switch. Yeah. Here's the drawings. Go and count how many of those are in there. So it can do stuff like that. And again, what you could do, again, if you've got different styles of light switches, so you could train it on all of those, and eventually it get clever enough to when you stick in a slightly different light switch, it doesn't go. Because again, you could use classic old technology, right? This is exactly what it is. Go and count all of those in there. Yeah. But what if it's slightly different? What if it doesn't quite recognise it?
There'll always be not a recommendation, but sort of a need for the human touch in there as well. Sort of the human factor will always be involved.
I think there has to be a sanity check as well, because if you go, right, go and count the number of light switches in this building, and it comes back and go, yeah, there's only 2. You go, this is a 10-storey tower block. How can there only possibly be 2 light switches in there? I'm not saying it would, but that's where you need the human just to go, hang on, something's not quite right here. Whereas if you had it all automated and fully, it'd just throw that in. And if you were, say, a big, huge cost model, where you say, oh yeah, give me the cost of that, you wouldn't see that level of detail, so you wouldn't see all of the mistakes. And it could go either way, and sometimes it balances out. Again, I've seen that sort of thing. Again, it's the same as when you make mistakes in models, because they do happen. Decimal points get misplaced and things like that. A lot of the time it balances out if you're very lucky. So I think that will be something they're going to come in. I think as well, the faster computers as well, I think will make it even quicker, even better. But it's always going to need those people to run it to go, this is what we want to do, this is the solutions. Again, the quick check. Again, I say more digital twins, better digital twins.
Is there any, this is just a generic question of, is there any cross between like and you're doing digital twinning and all the softwares that you include in that, and all aspects of digital engineering, is there any crossover with cyber at all?
Definitely there will be security, cyber implications that will all need to be connected.
Okay.
I think at the minute, a lot of times these are, whereas your chat GP or something like that has access to the whole internet. A lot of these things, I think, certainly initially will be held on separate servers, so it will only work on the information you've put in there.
Okay. And then it's protecting that data, and you don't want anyone else to get to that data that you've put in because it might be sensitive.
Yeah, unquestionably, a lot of the data we will be working on will be sensitive, will be the sort of things that you couldn't publish on the internet anyway.
Okay. Remember someone mentioning to just reminding everyone not to upload any sensitive documents to ChatGPT to sort of, I was at a talk and they said the amount of people that actually put sensitive documents on ChatGPT to like summarize it, not knowing that now you've fed that into the algorithm, now ChatGPT can pull on that elsewhere that wants someone who wants to know about that subject. Oh, I've been fed this data by someone about this subject. I can now pull that data, not knowing. I know there's certain models that you can say, yeah, don't learn from my data or don't like save it, but
if you trust that.
Yeah. Okay. Didn't even touch on lately you've been added to as a co-chair.
So yeah, recently I got the co-chair of the Supportability Modelling Analysis Community of Practice, which is a mouthful. It's run by
I was
Team
just trying to
Defence
think of what the
Information.
acronym for that would be.
SMNACOP.
Just comes right off the tongue.
But that's industry and the MOD sat down to discuss what's happening in modelling and simulation and where it's going and what we should be doing. Before I joined, they come up with a framework that they're trying to get implemented that will, if fully adopted by the MOD, will mean more modelling needs to be done in bids, in contract negotiations, to provide the MOD with the level of detail they've got.
Okay, so that's sort of helping the, okay, I see now. It's you're sort of helping that part where they then request it, and it makes it more of a.
Yeah, I think there was a question you asked earlier. I sort of alluded to it without saying that's what's going on. So again,
right. So there is a change coming, and you are part of that.
Trying to, but it's getting the buy-in for the 1 stars or the 3 stars or something like that. So again, but they're aware of what we're doing, and then they sort of believe in it. But again, getting that put into contracts that you must do this, and again, that's trying to not specifically say how you should do it. It's not saying, right, you must use this tool and do exactly this. It's you should be doing some sort of modelling to provide these sort of answers, to provide this level of detail. So they're hoping to get it implemented in the next 6-12 months.
How often do you meet, or
every 3 months?
Every 3 months. Are you enjoying it? Yes, loving it.
Yeah. No, I am. I've got a genuine passion for it, and I do believe in everything they're doing. I'd perhaps just like to have gone to 1 or 2 more before I ended up co-chairing it, so I know exactly what was going on, rather than just turning up.
I was going to ask how long was you part of it before you became co-chair? Was it quite
1 meeting?
Oh right, okay. So quite fast then.
1 meeting. The guy who was running it said, "Oh, this is my last one. Well, no, I'm retiring. I'm going to do the next one, then I'm off." And I had a quick sense. Well, if no one else wants to, I'm more than happy to do it. He said, "Yeah, brilliant. You can run the next meeting." Okay.
I'll ask you probably 6 months, or when I have you on again, to ask you then how it's going. But thank you for being the first person to sit in the seat. I hope you haven't found it a bit too daunting and sort of warmed up into it. Anything else you want to cover before we finish? I feel we've gone through the whole checklist.
I think so, yeah. I think we answered everything.
Okay. if you're happy, I'm happy. I feel that I have sort of an idea about digital engineering now, and just the total. The aim of the podcast is to learn about different areas of the company and two different aspects of defence and security, whether that's government, MOD, any of the security sector. From someone who came into this company, no military experience. There's more of a media background, so definitely none of the engineering background at all, or cyber. So this is definitely going to be eye-opening for me to sort of learn different parts of the company and different services.
But that's good, isn't it? Because again, it's like you can't get it right if you're learning something from it.
Yeah, I'm hoping whoever they're listening on Spotify, Apple, or YouTube, I hope somebody's learned something along with me. But yeah, thank you for being my first guest.
Yeah, no problem. Thanks. Yeah.
That is it for the first episode of The Briefing Room about digital engineering and what is it. Thank you for listening and or watching if you're on YouTube. I'm now going to have to finish off with the usual things that YouTubers and podcast creators say. So if you're on Spotify or Apple Podcasts or listen to us on YouTube, then give us a follow, give us a like, a subscribe. YouTube, you got to ring the bell so you get a notification every time we drop a new episode. There will be shorts on our channel as well, so just keep an eye out for the next episode, which will be around Secure by Design.